Intrigued? It is the ultimate automotive fantasy, discovering a wrecked exotic in a junkyard and repairing it for a fraction of its sticker price. This dream fuels the global salvage market. Every year, millions of dollars in written-off luxury vehicles pass through auction lots like Copart, attracting ambitious buyers who believe they can see past the damage. Take a common baseline project, a modern Range Rover Vogue that rolled into a ditch. To the untrained eye, the damage is purely superficial. Some scratched doors, a broken suspension arm, and a smashed window. However, visible damage is the least of your concerns. An SUV on the assembly line reveals the dense internal engineering hidden beneath the panels. Modern luxury vehicles are effectively rolling supercomputers. The sheer density of sensors, fiber optic lines, and interconnected modules makes traditional panel beating repairs nearly impossible. A salvage title is often a trap. The real cost isn't in the metal you can see, but in the complex structural and electronic failures you can't. Rebuilding a modern luxury car often becomes a cascading loop of failures, where solving one problem immediately triggers another. Even a simple task like swapping a crushed door is a nightmare. Because each door contains its own electronic module, the car's internal network often rejects the new part, triggering security and communication errors that require you to strip and reroute proprietary wire looms just to make a window roll down. If the crash triggered an airbag, the escalation is total. Replacing a single passenger side bag requires the complete dismantling of the entire dashboard, exposing a maze of modules that are often programmed to lock the car's ignition during an impact. These electronic control units form a software blockade. Even after the mechanical parts are replaced, the car's computers often refuse to clear fault codes or allow the engine to start without authorized dealer-level software intervention. Then there is the physical reality of modern aluminum. Unlike traditional steel, high-end aluminum panels warp and stretch under impact, making it agonizingly difficult to achieve factory-perfect door alignments once the chassis has been jarred. When you account for 3,500-pound headlight assemblies, 1,000-pound bonnets, and 500-pound windscreens, the bill for parts alone can easily exceed 15,000 pounds. If a mass-produced SUV demands this much software hacking and grueling labor, the hypercar tier moves from difficult to seemingly impossible. To find the highest tier of this salvage ladder, you have to go to Dubai. Here, in desert auction lots, you'll find the absolute peak of automotive wreckage, the million-dollar hypercar. These lots are full of vehicles abandoned by owners who couldn't keep up with payments or maintenance, creating a high-stakes graveyard of automotive financial ruins. One of the rarest finds is this crash-damaged Ford GT, a car so exclusive that only 1,350 were ever built. This car represents a unique engineering catastrophe. In the crash, a suspension arm was driven clean through the vehicle's high-stress die-cast aluminum tub, the very core of the car's structure. This aluminum tub is designed for rigidity, not repair. Unlike standard alloys, this high-stress die-cast material shatters and microfractures upon impact. Because it is bonded directly to a carbon fiber monocoque, the tub cannot be welded back together without compromising the structural integrity of the entire vehicle. The only safe fix is a total tub replacement, but the mechanic faces a corporate blockade. Manufacturers frequently prevent independent shops from purchasing these critical carbon fiber components. Brands like Bugatti take this further, actively blacklisting independent rebuilders from their parts networks, requiring that damaged cars be shipped back to their factory in France for any major repairs. At this level, a rebuilder is fighting the intersection of structural physics and corporate gatekeeping. Rebuilding an exotic car has evolved from a mechanical trade into a complex discipline of systems engineering and high-stakes negotiation. This tension sits at the center of the right to repair movement. Independent mechanics find themselves in a widening power gap against manufacturer monopolies that use software locks to maintain control over their vehicles. Surmounting manufacturer gatekeeping requires as much technical willpower as it does the capital to purchase the vehicle in the first place. Definitively, the idea that a salvage yard offers a simple bargain is a myth designed to trap the ambitious. The sticker price for a crashed supercar is an entry fee into a cycle of software warfare, of part scavenging and engineering survival.